Hey everyone, we're going to take our class notes on 11.3, day 2, where we're going to be graphing and solving logs. So we'll start with graphing, and to graph a log, I would suggest that you switch to exponential form. And we make a table and then we graph. So anytime we deal with logs, since we're not really familiar with them, a lot of the times you're going to see that it's best to switch to exponential form until we learn some more properties in the later sections. So let's go ahead and begin. Our first graph is f of x equals log base 4 of x. So I'm going to write this instead of f of x. We should know that that means the same thing as y. So I'm going to write y log base 4 of x. To switch forms, remember log base value equals an exponent. So when you think about exponential, this is the base, this is the exponent, and this is the value. So 4 to the y equals x. So when I make a table for this one, when I'm going to make a table, I need to focus on, well, x is alone, so I think it's best to pick my y values. So be careful, because a lot of times students will graph this wrong. I'm going to pick the y values, and I'm going to use -2, -1, 0, 1, and 2, and plug these in. So I get 4 to the -2 equals x, which is going to be 1 over 4 squared, which is 1/16 equals x. So my x is 1/16 when my y is -2. And then I can plug in a -1. 4 to the -1 equals x. That's going to be 1/4 equals x. When I plug in a 0, I'm going to get 4 to the 0 equals x. Anything to the 0 is 1. When I plug in a 1, I'm going to get 4 equals x. And when I plug in a 2, I'm going to get 4 squared equals x. So we're subbing in for y, we're picking the y values and figuring out what the x values are. Now I'm ready to graph. So in this case, I'm going to keep my y-axis counting by ones, but I'm going to, on the x, I'm going to count by maybe 4s. So on the x-axis, I'm going to count by 4s. And on the y, I'm going to still count by 1s. So I'm going to move over a 16th and down 2. So this is what a log graph looks like. I'm going to move over a 4th and down 1. X first, over 1, stay at 0. Over 4, up 1. Over 16, up 2. So logs and exponential. So this is going to approach the y-axis. So we have a vertical asymptote here. So it approaches, it's never going to cross over here. Exponentials grow quickly, and logs and exponentials are inverses. So a log actually grows pretty slowly. This one is growing. We could see a decrease as well, which I think we'll probably see in our next one. So first I'm going to write y equals log base 1/10 of x, switch forms, base exponent equals, so I'm going to write it as x equals, the base is 1/10, this is the value, 1/10, this is the exponent. So 1/10 to the y power, which means I'm going to, since the x is alone, I'm going to pick my y values to find x. Making a table. Again, I'm just going to go -1, 0, 1, and 2. I'm going to use 4 points this time. And when I plug in a -1 for y, 1/10 to the -1, that's going to flip this, that becomes 10. 1/10 to the 0, anything to the 0 is 1. When I plug in a 1, 1/10 to the first, I'm going to get 1/10. And when I plug in 2, I'm going to get 1 squared over 10 squared, which is 1 over 100. So I can see starting out pretty big, but going to smaller values. My y's I'm going to count by 1s. Oops. And then on my x, I'm going to count by 5s. Maybe I should do 2s. 5, 10, 15, -1, -2, -3. Okay, so in my table, I have to go 10 to the right and down 1. 1 to the right stay at 0, over a tenth and up 1, over 1/100th and up 2. So you're going to see that this one goes down in value. I wouldn't say, I mean, I guess I could say decay, but it's not going to decay quickly. It does go down in value, but slowly. And that is how you graph logs, by making a table. And now we're going to move into the solving piece. And so what it says in the notes, if you wrote them down or if you opened the PDF, is it says it's best to switch forms, try switching forms first. But this first example, what stands out to me is one of those special cases where it says if the base and the base of your value are the same, then this is equal to the exponent. So I could switch forms, but because I know that special property, I know that this just becomes an x. If these two things are the same, you get what's here. So this entire thing is an x. X equals 10. I'm going to switch forms so you can see base, exponent, value. So switching from logarithmic form to exponential, 6 to the 10 power equals 6 to the x. And what we learned with exponentials is if they have the same base, we can set the exponents equal. So we get 10 equals x. One way to do it, again, also, if you see that these are the same, you know this entire thing becomes an x. And then you would see x equals 10. Majority of these, when I see a single log by itself, I'm going to switch forms. So this is the base, this is the exponent, and this is the value. The x is alone, so solving for this, all I have to do is 3 to the negative 3, which is going to be 1 over 3 cubed. And that means I have 1 over 27 equals x. And this one, I'm going to go ahead and switch forms. Base is 1/3. Exponents 2 equals the value of 2x plus 5. 1/3 squared is 1/9. And I'm just going to go ahead and clear my fraction by multiplying everything by 9. And I'm going to get 1 equals 18x plus 45. I'm going to subtract over the 45 and get negative 44 equals 18x. Divide the 18, divide the 18, and then I will reduce that fraction. Oops. So 44 over 18 reduced is going to be 22 over 9. So you just cut those each in half. Did not need to use the calculator for that. 22 over 9. Negative 22 over 9 is our answer for that one. Switching forms here. Base, log base 36 of the 4th root of 6 equals x. Base, exponent, value. So base, exponent, value. I'm going to write this as 6 to the 1/4 because I recognize that if I have an x here, that becomes an exponential. When I have exponential, I want to write these with the same base. And I want to have it in exponential form on both sides. So 36 I can write as 6 squared. And then I have 6 to the 1/4. And this you should know. The 4th root of 6 is the same thing. Rational exponents last chapter. That becomes a 1/4. Same base, set the exponents equal. 2x equals 1/4. I'm going to multiply both sides by 1/2. And then I get x equals 1/8. So there's our solution there. You just have to be careful of where is your x, location of x, because we know that this, for example, can't be negative. And so we have to be careful and double check that to make sure that these are all solutions. And that is how we solve. Have a great day, everyone.